Dear friends, welcome to the Akash School Education video. Today we will learn about isotopes and isobars. In this tutorial we will learn about isotopes and isobars in detail. What is an isotope? We have already learned that ions are atoms that are either missing or have extra electrons. Let's say an atom is missing an electron or has an extra neutron. That type of atom is called an isotope. An atom is still the same element if it is missing an electron. The same goes for isotopes. They are still the same element, they are just a little different from every other atom of the same element. For example, there are a lot of carbon atoms in the universe. The normal ones are carbon 12. Those atoms have 6 neutrons. There are few straggler atoms that don't have 6. Those odd atoms may have 7 or 8 neutrons. As you learn more about chemistry, you will probably hear about carbon 14. Carbon 14 actually has 8 neutrons, 2 extra. C14 is considered an isotope of the element carbon. Similarly, hydrogen has 2 isotopes. Hydrogen, that is H, is a commonly found hydrogen atom which has 1 neutron and 1 proton. Deuterium, that is H2, is an isotope of hydrogen which has 2 neutrons and 1 proton. And tritium, that is H3, is an isotope of hydrogen which has 3 neutrons and 1 proton. If we look at the C14 atom one more time, we find that C14 does not last forever. There is a time when it loses its extra neutrons and becomes C12. The loss of those neutrons is called radioactive decay. That decay happens regularly like a clock. For carbon, the decay happens in a few thousand years. To be precise, 5,730 years. Some elements take longer and others have a decay that happens over a period of minutes. Archaeologists are able to use their knowledge of radioactive decay when they need to know the date of an object they dug up. C14 locked in an object from several thousand years ago will decay at a certain rate. With their knowledge of chemistry, archaeologists can measure how many thousand of years old an object is. This process is called carbon dating. In the diagram below, you can see 21380, that is astatine, which has a half-life of 125 nanoseconds or 0.0000125, whereas uranium 235, that is U235, has a half-life of 704 billion years, whereas uranium 238, that is U238, has a half-life of 4.46 billion years. This is the time these elements take for radioactive decay. Isobars. Isobars are elements which are chemically different but physically same. So, isobars are atoms of different elements having the same atomic mass but different atomic number. Since their number of electrons is different, their chemical properties are different. The light nuclei have unstable isobars. Heavy nuclei have isobars stable, and these occur in pairs. Suppose the number of protons of one isobar matches with that of one another, they are called mirror nuclides of each other. For example, neon and sodium. As you can see, they have same mass numbers but different atomic numbers. Here are some more examples of isobars in the table below. Thank you. For feedback and queries, you can email us on the given email ID.